The origin of the banana is Southeast Asia. The country like Indonesia, Malaysia, south from India is extremely important there.
So not Latin America?
No, Latin America, we have kind of mutations occurring, but the second center of diversity is Africa. For East African highland bananas, it's in East Africa, and for plantains, African plantains, it's in West Africa.
So there is a lot of diversity around the world.
Plenty of diversity. Well, here in the gene bank already we have
more than 1,500 accessions in the collection, and not only cultivated ones, but also wild relatives. So
and
those
some
are
improved
very
ones.
important.
The normal way of preserving crops is seed preservation. But there are some plants, like bananas, edible bananas, that do not produce seed, so that's why we have to preserve shoots. But shoots in the field, these field collections, they are subject to diseases, to hurricanes, and you can lose the collection. So that's why we have looked for an alternative, which is in vitro preservation.
Yes, in vitro preservation is actually a complementary approach to field conservation. We actually need both, because for the field conservation it's very important to characterize plants. The in vitro conservation is an approach that allows us to preserve the materials in a protected environment, protected from these pests and diseases, and also to have the material maintained in a standard way, and to distribute also material, to exchange material easily with other countries, because the phytosanitary restrictions are less stringent for in vitro materials than, for instance, suckers, which come directly from the field and which may have these pests and diseases.
And also in vitro collections, so in vitro material, you need the subculture, because that material still grows. And when you subculture, things can arise, like contamination, and that's why a long-term preservation method where you can keep the material for tens, hundreds of years would be ideal. And that's where the cryopreservation comes in.
And what's cryopreservation?
Well, cryopreservation is a way of storing material at ultra-low temperatures. In vitro conservation, you store the material at 15 degrees. It still grows very slowly, but still grows. With cryopreservation, we stop all growth, so all physical, metabolical, chemical processes are arrested. And this we can only do if we use ultra-low storage temperatures. So not 15 degrees, but minus 196 degrees, which is also the temperature of liquid nitrogen. Okay, so before we can start with cryopreserving an accession or a cultivar, we first need to produce a lot of rooted in vitro plants. So per accession we need about 200 of these individual plants from which we excise the meristems. These are in fact the kind of stem cells from our plant. Very small tissues of about 1 millimeter in diameter, sometimes even smaller. We protect with cryoprotective substances. We freeze these pieces very fast by putting them on a small piece of aluminium foil and dropping this in liquid nitrogen. So in order to store the material, you just have to plunge the material in liquid nitrogen, and that's it. And you can recover it after 100, 200 years.